We are in Algebra 1, Lesson 2-4, equations with variables on both sides. Today's date is Thursday, September 10th. And hold on, let me turn my screen around real quick. There we go. I don't want to, if I'm right-handed, I don't want the button on the right-hand side so it doesn't accidentally hit home. All right, September 10th, 2020. All right, so I can do the objective. It's pretty straightforward. Just solve equations with variables on both sides. And again, we're starting with a metaphor. And these get harder and harder throughout all of algebra. And eventually when we hit algebra 2, we'll have even more complex types of metaphors, I guess. Okay, so again, we're thinking in terms of being able to explain this to someone that's much younger than us. How? So if you say divide by 3, I guess that's as much as we can say, because you can say we take a third off of each side, which is maybe a little bit easier to understand, but still, how would we explain this to someone that's younger than us? Does anyone have a good first step to try to get the value of one of these unknown blocks? I see one hand. Okay, yeah, go for it, Yesenia.
So I was thinking, like, I don't know if it's gonna like to explain it to someone else, but for me, I was thinking, so like the 3 blocks that we know on the left, and then take 3 of the ones we know on the right, and so there's gonna be 4 left that we know, like the value on the right, and so probably it's gonna be that the question mark blocks are the value of the question mark block is 2 of the other ones. I feel like, I don't know.
Yeah, it is.
That's how I thought of it.
Yeah, so let's go ahead and cross off those 3 and cross off those 3. That's the equivalent of taking 3 blocks off each side. As long as you do the same thing to both sides of our scale, the scale shouldn't tip one way or the other. Nice. Okay, and then how? So I know that you got the correct answer of 2. I'm just trying to figure out how would you explain that?
So like there's 4 left, and there's like 3 blocks on the left. So 2 of those blocks equals 1 of the block on the left, and then the other one, like the other 2, another block, and then the mystery block is also 2 because it's like balanced.
Okay. Yeah, so I guess another way of looking at that would be like kind of, I think what we said yesterday is really helpful, like making groups. Like if I have a group of 1, 2, 3, a group of 1, 2, 3, that means since each question mark block matches to each group over on the right, that means that the question mark, as you said, is 2. Yeah, perfect. So that's one way to approach it. And then there's another way to approach it too, which is to take off a question mark block from each side. If I take, because they weighted the same amount, right? So I can just take off a question mark block, take off a question mark block, and then I have 2 question mark blocks equals to the 4, and then from there you can do groups again. I can say I have a group of 1, 2, maybe don't use black. Oops, what have I done? Make blocks of 1, or groups of 1, 2, groups of 1, 2. So each 1 question mark block is corresponding to exactly 2 of those 1 blocks. So either way, you get the same answer. I think we've said it now 3 different ways, that a question mark block is equal to 2 of those 1 blocks. All right, and yeah, let's go ahead and set this up in terms of the algebra. So on the left, obviously we had 3 of those unknown blocks, so I'll say 3x. Then we had an additional 3. And then on the right side, we had just 1 of those unknown blocks, so 1x, or just x. 1x and x are the same thing. And plus is 7. So let's try to match up the logic with what we did. So let's get someone new talking here. What do we do to both sides? Yeah, Ripley.
You subtract 3.
Yep. Subtract 3. That's the equivalent of taking these 3 blocks away from both sides. And Ripley, what do we have after we subtract 3 from both sides?
You'd have 3x plus x plus 4.
X is 4. I think you meant to say equal to right here. Is that right?
Oh, yeah, equals, sorry.
Yep, you're good. Thanks. Okay. And then kind of going with the step that I chose to remove the unknown block, one unknown block from each side of the scale, what would that correspond to as an action for our algebra? Jose?
Now you have to subtract x on both sides.
Perfect. And what do we have after we do that?
2x equals 4.
Perfect. And then our final step, again, someone new. Giorgio?
Just I think it would just be 2x, right? Or do we no, we divide 2x and then 2x to the other side too.
Okay. What are we dividing 2x by?
2x. I
So
believe.
2x divided by 2x like that?
Yes.
Not quite, because the trouble with dividing anything with an x in it, if x was 0, then we're dividing by 0, and that's like a mathematical sin. You've created a black hole. We can divide by something without an x in it, though. You can try again? Because you can want to think about it like this. Oh, yeah, go for it.
Divide 2x by 4? Or no, divide 4 by 2x.
So you can't divide by 2x, but think about it this way. Right now, x is being multiplied by 2. The inverse operation of multiply by 2 is what? The opposite of divide by that same 2, right? Yeah, so divide by 2 and divide by 2. You're dividing by whatever the coefficient is. So 2 is gone now, and there's our answer. X is equal to what? Giorgio?
X is equal to 4.
Careful here. Over here, 4 divided by 2.
Wait, no. It's x divided by 2. I mean, x equal to 2.
There you go. Yes, x is equal to 2. Thank you. And then we box it. Perfect. All right, so let's try a few of these in terms of just the algebra. All right, we have our variable is b. It's the same type of problem. I can change that letter to whatever I want. I could have done a heart or a star. I chose letter B because it's easier, right? Okay, 3b plus 8 is equal to 6b minus 1. Anyone want to take the first step? 2 hands. Haiti, go for it.
Minus 8.
Minus 8 on both sides. And what do we have after we do that?
3b plus. Wait, I'm looking at my notes. Oh, 3 equals 6b minus 7.
Okay, there is a tiny little error in here. And if you can find it, Haiti, that would be great. And if not, someone else might be able to find it. It has to do with,
Only put b. Oh, wait, never mind.
yeah, so the 3b and 6b are fine. It's something to do with right here.
Oh, add.
Okay, so what does that mean?
Is it +7?
No, it's not +7 because I mean, these are both negative values, so the answer should also be negative, but it's not -7.
Oh, it's 9.
Yes, there it is, -9. Okay, and then just off to the side, just for everyone else to make sure that you can see what she saw too. If I have -1 -8, that's the same thing as asking -1 plus a -8. It's kind of a keep change, and a -1 and a -8 adds to -9. Perfect, thank you. Good first step. What should we do next? Anyone else? Hopefully someone new. What is our next step after doing this? We're trying to get all the variables on one side. Yeah, Diego, go for it.
You subtract 3b from 6b.
So minus 3b from 6b. Okay, was there a new
Yes.
equation now?
Let me see. Subtract 3b plus 6b. It would be 3b. It would stay as 3b.
On the right or the left?
The right.
Okay, so the right is 3b. So what should the full equation be then? I see your hand, Jose.
I think it has to be negative, I mean, yeah, -6 plus 3b, like on the other side because the 9 is over there. Or it doesn't matter.
Okay, you wanted to put the variables on the right hand side instead of the left, or on the left hand side instead of the right hand side?
Yeah, because the 9 is already there.
Okay. Yeah, so we might go with that. Let me hear what Diego has to say. What's the full equation that you would have after subtracting 3b on both sides?
You just have 3b minus 9.
Minus 9. And then what about the left-hand side of the equation?
That would disappear.
It would disappear, yeah, because we're subtracting 3b on both sides. So we'd have 0, which is fine. It just means that we have to move either the 9 to the left or we have to move the 3b to the left, one or the other. So you can go this path. And Jose kind of found the shortcut, which was instead of subtracting 3b on both sides right here, if we instead subtracted 6b and moved the 6b over here, then we would kind of skip a step. But we can still get the same answer. So someone else, who wants to move like the -9? We could add 9 to both sides, or we could subtract 3 on both sides, 3b on both sides. Zeke, what do you want to do?
I was gonna say you could just add 9 to both sides and you'd end up with 9 equals 3b.
Okay, yeah, let's do it. So 9 is equal to 3b. And running out of room here. But we're basically there. We have one final step. You want to do a Zeke?
Sure. You could divide each side by 3.
And then that would give you what for your new equation?
That would give you 3 equals b.
Yeah, there it is. All right. Can you guys give me a fist of 5? How well are you following the work here? How well can you do a similar type of problem if I just switch the numbers around a little bit? I'm getting 4s, 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 5s, 4, 3, 4, 4, 4. Okay. So doing pretty well. Let's keep going on to number 2. This one is solving for n. 2 plus n plus 9 is equal to 4n plus 6. So I talked about this yesterday, but I should review it again today. Whenever we solve an equation, typically the path looks like this. So if we have our order of operations, P, E, M, D, A, S, and again, parentheses, exponents, multiplication, division, addition, subtraction. Typically the way that we want to do our work is we first want to go down and then back up for PEMDAS. So PEMDAS means, I guess if we're doing this in words, it means simplify each side first, then solve. The reason that I'm pointing this out now is because if we look at the left-hand side of the equation, this 2 plus n plus 9, that is not simplified. I can combine like terms and make that a smaller and more simple expression. So going forward with that, what does this left-hand side of the equation, what is this expression over here simplify to? 2 plus n plus 9 is the same thing as what? Ripley?
11 plus n.
Yeah, exactly. 11 plus n. All right, so we've simplified the expression on the left. Now we can write the equal to sign. Is there anything that we can do on the right? Can we simplify that any further? Seek?
Oh,
No.
never mind. I was just gonna like say the next step.
Oh, you're ready for the next step. Okay. I hope you guys are nodding your heads. No, there's nothing we can do. These are not like expressions. This has an n in it. This doesn't have any n in it, so you can't combine them. So we have to leave this as 4n plus 6. All right, and then we solve. Now it turns into the exact same steps that we had in example 1. We solve. We're going back and undoing operations. We're starting to look for addition or subtraction that we can undo, and then eventually we're going to undo multiplication and division. So what is a good first step for us? Or I guess a second step. I've called on you like 2 times already, Zeke. I'm going to wait for someone else. You're our backup though. Yeah, Giorgio.
Subtract the 6 on the right side from the 11 on the left side.
So subtract 6. So you're really just saying subtract 6 on both sides, right?
Yes.
Perfect, yeah. So subtract 6 on both sides. What is our new equation after we subtract 6 from both sides of our equation, Giorgio?
5 plus n equals 4n, I believe.
4n, okay. Yeah, a great second step. I need another step now. Next step. I see a bunch of hands. Yeah, Alden.
Subtract n from both sides.
A great step, yep. What happens after I subtract n from both sides? What's our new equation?
5 equals 3n.
Yeah, and I like how you made it so that we had variables on one side, 3n, and then constants or normal numbers on the other side, 1 on each side. Okay, and finally, the last step, what are we gonna do?
Divide.
Yeah, Jose, quiet raise hand, you got it? Yeah, what are we gonna do, Jose?
We can divide 3 sides.
Yep. So divide by 3 divide by 3. And what's our final equation then, Jose?
It's like 1.75, I think.
Oh, you can leave it as a fraction. You can just leave it as 5/3. It's fine.
Okay.
5/3 is equal to n. Right. Yeah, I know that in elementary school, we're taught that improper fractions are scary and bad. You need to turn that into 1 2/3 or 1.666666 repeating. It really doesn't matter. I mean, it's good that you guys know how to do that and it's a useful skill. But for me, just leave it as an improper fraction. That's fine. Leave it as 5/3. Same thing for Khan Academy. Enter 5/3, you'll get it correct.
The answer was like 1 1/3.
1 1/3. I think you have to be careful there because if you do 1 1 1/3, that's the same thing as 1 1/3, which is 4/3. So I think this number has to be a 2. Does that make that a 2 and therefore that a 5?
I just got confused.
It's fine.
Because you have to multiply times 1 times 1/3.
What do you mean multiply by 1 1/3?
Oh, like, never mind. I forgot.
Okay. Yeah, and just as a review, if we do need to turn 5/3 for everyone else into a mixed fraction, so I take this many away from the numerator, so 5 minus 3 over 3, and then since I've taken away exactly the amount of the denominator, it's 1 and that number, which is 1 2/3. All right, raise your hand if you need more time to copy this down, otherwise we're going to go on to the next page. No one's raising their hand, and we're on to the next page. Okay, example number 3. Slightly harder, same kind of type of problem. For this one, I want to try doing really quick breakout rooms where I'm going to pair you guys up, and then you guys are going to check your answer with someone in your group. Raise your hand if you need more time to copy this down. No, okay, I'm going to go ahead and set up the breakout rooms. So I'm going to